All right, folks, let's get going. I'm Ben Goldstone with Dell Technologies. Today we're going to talk about automating VXLAN networks with open source CI/CD tooling. Before we jump into it, I want to give you a brief overview of what we're going to be talking about today. We're going to start by discussing the state of networking as it exists today, talk about what is CI/CD, the difference between continuous integration and continuous deployment. I'm going to walk you through an example build of what exactly a CI/CD pipeline looks like in concept. We'll review a diagram, and we'll also review a video that I have for you where I'll actually make some modifications to a network utilizing a CI/CD pipeline, a very basic example. We'll then talk about the tools that I use to build out that example and some alternatives that you might utilize to build out your own version of a CI/CD pipeline, as well as some tooling that you can use to go beyond this simple example for testing, validation, and so forth. So, what is the state of networking currently? We, of course, are all familiar with our old friend, the CLI, how networks have been configured for decades at this point. But automation is starting to creep into most of our networks these days, whether that be via Ansible, actually just running Python scripts, or leveraging Terraform, etc. Many of us are starting to roll out automation in our networks because automation can reduce errors. And many of the networks that we operate today are starting to scale beyond what is really acceptable to configure with just the CLI. Ultimately, snowflakes are not your friends. By a show of hands, how many folks here have run into an issue where a snowflake configuration bit you in the butt? Maybe somebody didn't update an Excel spreadsheet, didn't say a DHCP, server was on a network segment. I know I have. I'm guessing the rest of you either have or you're lying, one or the other. So, why embrace this new tooling? Why embrace automation, but beyond automation, CI/CD itself and the workflows that it offers? Well, traditionally, changes to a network have been focused around change windows, periods of time every few weeks, every few months, where you have reserved time to push out a large set of changes into the network. Ultimately, that builds inertia in the network, in that you have devices that have been running for months, years, etc., which means while they have been stable, they haven't received any security updates. You also have large change sets typically being pushed out in these change windows instead of small incremental changes. So if something does break, you have a large degree of changes you need to troubleshoot. A lot of that has been because the reward structure within networking has fundamentally been focused on stability, not agility. But in our modern day infrastructure, and with businesses operating as they do today, that dynamic really needs to change. Businesses need to view the network as something that enables business agility, not hinders it. So we need to find a balance between those two. Traditionally, focusing on stability over agility has fostered a culture of no. How many in here have been told, you guys in cybersecurity, you guys in networking, just say no to me all the time, right? Can't ever get my application deployed because you say the change window is 2 months from now and you can't accommodate it. We need to rebalance that for the sake of the business and for the sake of our relationships with our counterparts within business. The other thing I'll touch on here is that fundamentally documentation that isn't code, that exists in a separate document, spreadsheet, whatever, is always out of date. That's been my experience. I'm sure many of you share that sentiment as well. And enabling these new GitOps-focused approaches really enable us to ensure that the code itself is the documentation. You need to know what's running in the network. You can reference what is in the GitHub repository and correlate that against what has been run in your CI/CD system to see this is the state of the network. An example I want to reference in terms of dangers of not using automation are the Knight Capital Group incident that occurred in 2012. I'm sure some of you have heard of it. In brief, a technician was set to roll out changes to 7 out of their 8 servers. These servers processed, as I understand it, equity orders they only rolled out those code updates to 7 of the servers. And what happened when the market opened on Monday or whatever the next day was, is that on that 8th server, there was a piece of code that no one realized still existed, hadn't been used in years. And when triggered, it wound up ordering over 397 million shares at an incorrect value of 154 different stocks. And in the process of 45 minutes before anybody caught that issue, Knights Capital wound up losing over $440 million in value. Ultimately, they were acquired by another equity firm and rolled into how they exist today. That's an example of how automation might have saved an organization. Now, I will also say that I'm sure as plenty of us have experienced, automation can, of course, shoot you in the foot. It's a double-edged sword in that way. But what we're going to be talking about in part today is leveraging not just automation itself, but other technologies like testing into a full CI/CD pipeline that help prevent, ultimately, you shooting yourself in the foot with automation. So, what is CI versus CD when we're talking about building a CI pipeline? Continuous integration is fundamentally the practice of regularly integrating code changes into your code base once a day, multiple times a day, et cetera, to ensure that everybody's playing off the same sheet of music, so to speak. Whereas continuous deployment is taking those changes and testing them, staging them, and deploying them into your environment. The example we'll walk through today is tooling that is more focused on the CD side of the equation. This is an example of pipelines that we built out at Dell for a number of customers. And in this diagram, you'll note that we actually try to create a full closed loop. What we'll focus on in the example today is actually about the first 2/3 of that loop, not including so much the monitoring and the ServiceNow ticketing, but instead the simple act of somebody puts in a request for change, typically outside the networking organization. Somebody needs to roll out a new application or whatever it might be. That will generate a ticket that is presented to the networking team. Networking team picks up that ticket, and instead of logging into a CLI at the appropriate time and changing network configuration, they will propose a set of changes to the network that are fundamentally encapsulated in whatever automation tooling is used. That might be changes to Ansible scripts, Python, Terraform, whatever the tooling is. That can be reviewed by colleagues and or pushed through the CI/CD process to run tests against, for instance, a test network, which is part of what we'll look at today. And the way that that interaction happens is by an engineer, once they've created those changes, pushing that to a specific branch within your Git repository. That will trigger step 4 here, that CI/CD trigger, to kick off the drone. In this case, we're utilizing drone. Kick off the CI/CD process. And fundamentally, you can use Ansible itself, Ansible's automation platform, AWX Upstream, et cetera. The goal here isn't necessarily to be prescriptive, but instead to give you an example of what a CI/CD workflow looks like. So let's walk through a brief video that gives you an example of actually implementing some changes via CI/CD.
All right, everybody. Thanks for joining me on this today. In this example, we're going to be going through a simple lab demonstration of updating a VXLAN network with an additional VRF for a new tenant, the VNI to VLAN mapping configuration that tenant will need for passing traffic, as well as the VLAN itself. We're going to be adding those components via Ansible, and we have a couple other tools we're going to be using for this example today. For actually running our environment, we're going to be leveraging GNS3, as you can see here. Within that environment, I have a very simple VXLAN setup with 2 spines and 2 leaf switches. In addition to GNS3 and Ansible, we'll also be leveraging a drone CI/CD system, which I have deployed in the cloud, the drone runner, which I'm actually running on my local machine as it's attached to this GNS3 environment running in a virtual machine, and I will be leveraging GitHub for the actual Git repository. So that's the tooling we'll be using today. If we go into these two leaf switches, you can see leaf 1 on the left, leaf 2 on the right. You can see that we don't currently have that new VRF for tenant 1, nor do we have any specific VXLAN VTEP mapping configurations for that VNI to VLAN ID mapping. And we actually don't even have specific VLAN 11, that will be leveraging for that traffic. So, with that in mind, let's go take a look at the Ansible playbook. So I've created a simple Ansible playbook just to try to keep this lab straightforward for today that has a variety of configuration parameters. In this playbook, we'll actually leverage API calls through Ansible to create that VLAN 11, to create the VXLAN tunnel mapping configuration to actually map the VTEP and VLAN 11 to VNI 101. And then we'll go ahead and create the tenant VRF and assign the VNI 101 to that tenant VRF. So let's go ahead and try that. I'm going to go ahead and check my Git status. I've modified a variety of configuration files to actually perform those API calls. I'm going to go ahead and commit that and push that to my repository. And that will, of course, kick off a new run of my CI/CD environment. The way that that works, just to touch on that briefly, is within my repository, I do have a drone configuration file. This has been kept as simple as possible for this example. And so I'll actually be just calling one executable, which is Ansible playbook, referencing my inventory that defines my hosts, and then this playbook we just went over for all those API calls. Within my inventory, again, keeping it simple, I have spines and leaves broken out logically. However, this playbook will only target, for this specific example, leaves, as we don't need to add VLAN VNI configurations on the spines. So, as of that update, the system did go ahead and clone this repository down to the runner. It then ran that Ansible playbook, and we can see the output here. You can see it did change both leaves on all counts for creating the VLAN, for creating the tunnel map, for creating the VRF for tenant 1, and associating that VNI to that VRF. Nothing failed, and it executed pretty quickly, 7 seconds from kicking that off to it completing. Now, if we return to our leaf switches, we do indeed have VLAN 11 is now created. Let's look to see if we have that VRF for tenant 1, which we do. And let's go ahead and look at the running configuration for VXLAN for the VTEP 1. And we can see we do have those two mapping statements to associate VNI 101 to VLAN 11, which will of course be assigned to that tenant, and in this context also assign VNI 101 to the VRF for that tenant to keep their traffic segmented. It's a great example of how to leverage CI/CD system for rolling out changes in an automated, controlled, and auditable fashion to multiple leaf switches within a VXLAN EVPN fabric. Thanks, guys.
All right. So that was walking through our example workflow. The tools used, as I mentioned, were GitHub for version control, GNS3 for the virtualization platform, Drone in the context of the CI/CD system, running the server in AWS in a virtual machine, and the runner in my local lab environment, Ansible for the automation tooling, and Dell Enterprise Sonic for the network operating system. But again, the point here is not to be prescriptive. This is just to get you up and running with a basic CI system for automating networks. You instead could use any of these alternatives. You could combine GOGs for version control, target physical hardware, utilize Jenkins instead of Drone, maybe leverage Python or Terraform if your network operating system supports it, and then execute that against NXOS, EOS, Juniper, depending on what your platform is. And of course, this can be integrated to not just automate your on-premises network, but also automate changes against your cloud infrastructure, for instance. I wanted to touch on a couple of common questions that come up when talking about this type of deployment. And I didn't go into this in depth in the video, but there is the concept of promotion through the pipeline stages when talking about a CI/CD system. This is a config snippet from a drone configuration file where it specifies on the event of promotion, which can be done through the CLI, the drone CLI, or within the drone GUI itself. In the little upper right-hand corner, you get the option to promote to the next stage if you want to. You can then target production for this next stage execution. And the specific command, to keep it simple, you can have a very long, complicated list of commands if you want. But in this example, our inventory file will simply change to target our production inventory file instead of our GNS3 lab inventory file. Another common question that comes up when talking about this type of thing is, well, I have infrastructure across multiple data centers, and then for whatever reason, security or otherwise, they aren't necessarily connected to a common location. So how can I target runners in specific data centers to execute changes against a specific fabric? In the drone ecosystem in particular, other CI systems do this in a similar fashion. You can match tags, which are arbitrary key value pairs. So in this example, I specify that the data center must be US, California, LA, DC1, and just to extend this example, it must also be accessed by a bastion at LAX1. Use tags as works for you, but the point is that this would exist within the drone configuration within the repository, and on the runner itself, you'd have the same set of matching tags. As long as all tags match, that runner will be the runner used to execute a pipeline run. So that enables me to not accidentally send an update that should be going to my LA data center to Iowa, for instance. Due to the time I had available, I wasn't able to extend this, and to keep it simple, I didn't necessarily want to either, with some examples of full testing. Though I am going to be building out some example blogs that I'll be posting soon that will take that simple example and extend it utilizing some of these tools, including Batfish for formal verification, PyTest, where I'll build out a variety of unit and function tests being end-to-end functionality of the network, so using ping or similar tool to actually test going through the entire leaf-spine fabric in my test environment, and or unit testing to see if a BGP peering relationship has been established that I expect. SUSE-Q is another open source tool that can be used to examine the state of your network pre and post deployment to say, instead of trying to look at every device individually, utilize SUSE-Q to gather that information in a way that I can then readily query to see post deployment, in effect, did I break anything? Netbox can be utilized both during the deployment, referencing your source of truth to see what VLAN is available. But also, after the deployment, you may want to have a step that updates Netbox to say, okay, this VLAN is now in use. Rocket Chat is an open source alternative to Slack, which gives you the option to integrate chat ops notifications so that your team knows somebody has kicked off a process. And this was the result of it. With that, I leave you with allow humans to innovate, machines to automate. I thank you for your time.
So your configuration change included multiple steps, right? You know, the VLAN, the VRF, the mapping. What happens if one of those steps fails?
Ansible will fundamentally return a message that one of those stages has failed. And depending on the configuration you have within your config file, you can either just flag that and continue on, or you can have that interrupt the pipeline. So you can, if you have a multi-stage pipeline and one of the stage fails, then you can return this failed, notify your user.
But what happens, I guess my question is, does this process ensure the, the atomic nature of the change, right? So that,
Sure.
There is no hanging configuration pieces in the switches and
Sure.
it's all cleaned up if it's...
In the current example, it does not, but you can utilize that tooling to, say, effectively roll back changes. You can also, as an alternative to utilizing Ansible, which frankly is not my favorite tool, but it's used in this example, you could, for instance, generate an atomic change set that you then do a config replace on the device with and see if then the device passes testing. Again, the goal would be to do this in a test environment using GNS3 or similar platform as a digital twin and ensure that that does execute correctly. Once that is executing correctly in that virtual environment, you can then move it to the additional environments that you're targeting, ultimately to production. But it's a great question.
Yeah, thank you, because probably many of us, failed Ansible playbooks and ran
Oh yeah,
many
working
times
on this, I can't tell you the number of times that it didn't work. And yeah, you can see there's a bunch of red lines. And so, yep, behind you.
So the example you had here was, one set of switches that were to update it. And in fact, I would argue that it's actually easier to do it by CLI, right? Because you just log in and make the change, whereas we added a lot of complexity here. I
Sure.
think the use case, though, where I'm more excited is, what if you need to change a parameter on like 1,000 switches or something like that, a BGP setting or something, right?
Right.
But I'm also more worried about that use case, right? Because now I hit submit, whatever Terraform apply or whatever I'm using, right? And then all of a sudden 1,000 switches get updated. It's like, what are your thoughts there on how to set that up in a safe manner?
Sure. No, absolutely. As I said before, you can absolutely shoot yourself in the foot just as easily as effectively rolling out changes. And that's part of the reason why I recommend utilizing that virtual environment to try to roll out that change initially. And yes, it's a simple, contrived example. I wanted to keep it simple and straightforward so that people can replicate it and utilize it for what they want to. So I would definitely recommend roll it out in that test way. And as the feature of config replace becomes more available on more platforms, utilize that to your advantage. So ensure, as for instance, one of those first steps of kicking off the pipeline, you don't just jump right into actually automating a rollout, but do a config backup of all devices that'll be affected, right? Store that somewhere, ensure that they're stored and valid, and then roll forward with your changes. That way, if you need to roll back, you can have a secondary process that through automation just takes those configs that you pulled, rolls them back onto the devices. So again, the idea here is to focus on utilizing automation to make those logical operations easier. Any other questions?
Do you know if there's like any open source project that you can add to the CI/CD pipeline so they can basically schedule like these deployment as a job, like let's say in 2 hours, in 3 hours?
Sure.
Instead of just doing it right now. So
I think it depends on how you utilize Drone itself. I'm still learning the tool. There may be a native way within Drone to schedule that. But alternatively, you could certainly have within the execution of your script a delay that you write in. So you can say, wait 2 hours before actually running this pipeline. You have a long running pipeline, but you can also specify within the Drone file, don't error out after 60 minutes. You could extend that to 3 hours. So, any other questions? Thank you guys. And this and other articles related to it will be posted on my blog, which you're welcome to reference. The video will be up there, and that'll be up probably next week. So thank you for your time.